Hello and welcome back to our data structures and algorithm series. In this video, we want to look at the linked list traversal operation. So we traverse a linked list starting from, yes, you guessed it right, the head. So you have to first access the head so that you can see the address of the first node. Only after visiting the head can we be able to visit the first node. Then when we visit the first node, we print the value of the first node. Then we look at the next or the reference part of this node. We see the address to the next node. Then we go to that next node. And so on and so forth until we get to the end. And how do we know that we are at the end? Yes, you guessed it right. When we encounter the null value. In Python, it's actually none, okay? Meaning the emptiness or the lack of a value at that particular memory location. So that is how we determine the end of a linked list. So let's jump right in and see how to implement this in Visual Studio Code. So in our previous video, we actually mentioned about the print list function. So this is the print list function. The purpose of this function actually is to traverse the linked list as it prints the data of each node. So actually this is a traversal. This is a traversal method. So instead of actually writing another traversal method, we're just going to use this for this purpose to learn, okay? So as we said, we have to create a method. Of course, we have to pass self. Then we have to begin by getting the address of the first node. How to get that? We create a variable. You can call it anything you want. For me, I'm just calling it current node. Then you equate it to the head. So self.head. Remember, when we were creating this linked list, we actually created a head on the initialization function, and when we created a node, we actually assigned it here at the insert beginning. So that's the same head that we are referring to. Now after that, as you might have guessed it, the next thing is to now go into a while loop. So the purpose of the while loop is to loop through this object until it actually finds a none. Remember when we were printing the objects, it's actually just the address. So while the address is still available, then do something. Otherwise, when it encounters a none, then it's going to stop the while and it's going to print none at the very end of the list. Okay, so let's go inside the list. What we are doing inside the list is to print, and we're actually printing the current address for the object.data. So you're simply printing the node data. Then I explained this in the previous video, the arrow. Then after printing the data, we want to move the current node to the next node. So how to do that? You equate current node is equals to current dot next. So if you do that, then it will move the next pointer to the next of the next node. Okay, so let's just run this again. If we run this, of course, it's just the same program we had run before. So we are going to have A, and then B, and then C, and then D, and then eventually it's going to print none. But let's try and visualize this by using the debugger. So I'm just going to come here at the beginning of the print list function on line 30 and click on add breakpoint. Just to the left of line 30. So I'll click that. Then I'll come here, run and debug here. Okay. Then I'll click run up here, the play button here. So I just want us to observe how this print list function really works, how the traversal works. Now, it's just putting the breakpoint there. You can use this down arrow here, up here. I hope you can see it. So if I press next, it's actually going to go into the singly linked list to create the object. So I'm just going to rush through this until we get to, for you, you can just go slowly so that you see how the objects are being created. But for me, I'm just going a bit faster because that is not what I want to show you. What I want to show you is the traversal. So good, great. So now we are here on line 47. So you can see the pointer. That is where we are. So we just want to call the print list function. So you're going to see how that will behave. So if I click next, we now go inside the print list function. You can see here. Now, if I can just allow me to extend this a bit, you can actually see that we are on line 31 now, and we have an object at this particular memory, which is actually self.head. Now, if I move further to the next line, you can see that now we've created the current node. You can see here. Let me just highlight it. You can see, because we've just executed this line. Sorry. I just intended to highlight. Whoosh. Seems to be a problem with my mouse. Okay. My mouse is not working as expected. But this is the line that I'm showing you. This one, current node is equals to self.head. So that's exactly what we've done here. So we've created a variable called current node, and we are storing actually on it the value, the address of the head. Okay, so let's go on. So we are now moving into the while loop. So look what happens. I want you to especially keep note of this memory address and the value of the current node. So you can see right now, you can just keep tab of the 3 last. So right now is 6D0. So that's where we are pointing at. If we click next, we now move into the while loop. Now in the while loop, we expect that it's going to print current node.data. So just focus on the terminal here as I click on the stepper. Yeah, good. So now it's printing actually A. You can see it's printing A. And then on line 34, which is where we are right now, if this is executed, we expect this current node variable to change and point to the next node, because now current node is equals to current.next. So just watch here how this is going to change. If I click next, you see, so now we have a totally different memory address. It's ending with 1E0. So it's totally different from the previous one, meaning now we've moved on to the next node. And for sure, if you look at the terminal, when we print, then we have B, current node.data. Then again, if I go a step further, the memory address changes because we've changed. We've executed current node is equals to current node.next. So again, now it's BA0. So if we go into this while loop and print, we now print C. Now see what happens when we get to the end, because we know that we only have A, B, C, and D. So when we get to this, when we execute now line 34, current node, which is now C. So what we are saying is C is equals to C.next. So if we press next, now it's going to point to where D has been stored, EE0. And if we go next, we are going to print D. So actually, this is where I meant to say you need to look how the current node variable changes now, because now we are at the end. So we know that d.next actually is supposed to give us none, because we have not stored any, it's not pointing to any other node. So if I just click next here, look at how the current node variable is going to change. If I click next, you can see that the variable now is none. And now line 32 is going to execute like this, while none. So when it gets none, it's the same as false. And therefore it's going to exit from this particular loop, because current node is none now. So if I click next, you see now we go to line 35. So we are no longer inside the loop. And now if I click next, we just print none. And that is the end of our program. So I hope through that debugging, you have been able to have a clearer picture of how traversal really works. In the next okay, just before we look into the next one, here, if you want your program to be more readable, you can actually write a while current node is not none, like that. So this is the other option you have. So if you run this, if I save and run this, it should be able to still give me the outcome that is expected. So anytime current node is not none, it's going to execute. But when it's none, it's going to stop the while. So in case you feel like just using current node alone is not very readable, you can use the is not Python keyword. Okay, so that is the end of this particular video. In the next video, we will look at how to insert a node at the end of a linked list. So thank you for staying to the end. See you in the next video. Bye for now.